Okay, good afternoon, dear students. In last class, we discussed about the different salts. That is a category under the different salts comes under the strong acid, strong base, and weak acid, strong base, and another that is a strong base, weak salt. That is a weak base, weak base. Last one is a weak base and weak base. First one is a that is first one strong acid versus strong base. Second one is a weak acid versus strong base, and third one is a titration of strong acid with weak base. And finally, fourth one is weak acid and weak base. In this category comes some salts and ionic product of water, and all salt hydrolysis is completed, ionic product of water is completed, and today class the conductometric measurements, the application of conductometric measurements. In this there are four titration. The conductometric titration are the four titrations. One is I already told, that is first one is a strong, second one is a weak and strong, third one is a strong weak, and fourth one is a weak weak. In the class I am going to discuss about the conductometric titration. Conductometric titration. The unit name is conductance. This is a conductance, and in this the conductometric titration. Here you are using in conductometric titration the conductance grids here. The conductance grids are using in this conductometric titration. Here the conductometric titration are those titration in which the conductance measurements are made use the determining the endpoint. Here the conductometric titration or measurements of the endpoint. Here you use the endpoint. It comes finally, that is a equivalence point. Here you are using any of strong acid and strong base HCl versus NaOH. You are using this hydrochloric acid and sodium hydroxide. In this, the graph comes like this, and this increases. This type here, this is a the short point is comes here. This is a equivalence point. Equivalence point, that is a end point. Here you are measuring the end point HCl versus NaOH, or you can take that is a weak acid versus strong base, or strong acid versus weak base, or weak acid versus weak base here. For the conductometric titration, in this conductometric titration, the measure of the end point of the conductance here, that is a equivalence point. Here it comes end point of the reaction, such as the acid, alkali, and you are using acids and alkalis. Acids means that is strong acids and weak acids. Alkalis, that is a strong alkali, that is the strong bases, and weak bases. You are using this here. The alkalis, some displacement reactions or precipitation reactions are occur in this conductometric titration. Here the displacement reaction, and another that is the precipitation reaction. Precipitation reaction. This is it undergoes in conductometric titration. One is displacement reaction or a precipitation reaction. And here in this titration, the advantages for this, the advantage for using this conductometric titration. Here the advantages are is that taken the conductance. You are measuring the conductance of a solution at a constant temperature. You are using the constant temperature and you are measuring here the conductance of the solution, that is strong acid versus strong base. And measuring the conductance at a constant temperature depends upon the number of ions present in it here. These if conductance is obtained, this is depend upon the number of ions present in it. Any of the solution, you are taken solution. Here the sodium hydroxide you are taking in a burette, and the HCl is you are taking in a beaker. That is 50 ml upon only and the presence of ions in that solution here. And then mobility. For this purpose, the titrant means you are adding the burette. In burette is present. In burette, the presence of sodium hydroxide. You are added in burette, that is a sodium hydroxide. In burette solution, presence of a sodium hydroxide. This is known as a titrant. Sodium hydroxide. This is known as a titrant. Here you are adding the titrant is added from a burette into a previously measured volume of the solution to be taken. Here previously measured, that is you are taken 10 ml, 20 ml or 25 ml. You are already in this measured volume and you add this titrant from the burette here. This titrant means that is you take any of the example here titrant. You take a weak alkali, that is ammonium hydroxide is present in the burette, that is a titrant. And volume is taken in a known volume is taken in the conductance cell and the graph has been plotted. The volume of the titrant against the conductance is written. After from this we get a two linear curves. I have already drawn the two linear curve graph. Here the conductance, observed conductance and the volume of titrant, that is the volume of NaOH added. And here we get two linear curves and the point of intersection will be the end point here. This is a graph. Here this is a volume of NaOH, volume of titrant added, volume of titrant added, volume of titrant added, and here according to this conductance. Okay, for example, here you get this type of curve. This type of curve and these two linear curve intersect at this point here, at this region, at this area, intersected this area, and this is known as a equivalence point or a end point. This gives the end point. The intersection area, they intersect two linear curves, and the intersected two linear curves will get a one point. That point is called as the end point here, and thereby corresponding volume of the titrant will be required to neutralize the solution of conductivity cell here. When you obtain the equivalent, that is equivalence point, and the solution is neutralized here. You get this point, that is a equivalent point, and the solution is neutralized, and the nature of graphs are obtained in a certain types of titration. Certain types means the conductometric titration. There are four conductometric titrations are there. Okay, we discuss one by one the four conductometric titrations. Okay, here first one that is the titration of a strong acid versus strong base. Titration of a strong acid versus strong base. Titration of a strong acid versus strong base. Strong acid versus strong base. This is a first conductometric titration, and second one is a titration of a weak acid versus strong base. Weak acid versus strong base. Next, third one, titration of a strong acid versus strong base. Sorry, weak base. Weak base. This is a third conductometric titration, and fourth one, titration of a weak acid versus weak base. Okay, here this is a titration of a strong acid versus strong base, and second one is a titration of weak acid versus strong base. Third one is a titration of strong acid versus weak base, and fourth one is a titration of a weak acid versus weak base. We discuss the first one. We will discuss here. The first one is the titration of strong acid versus strong base. Okay, first one here the graph is according to the strong acid versus strong bases. Here the strong acid, you take example is HCl. Okay. Here the strong base versus the strong base NaOH or KOH. Here HCl versus NaOH. HCl is a strong acid and NaOH is a strong base. According to this, the titration of strong acid versus strong base, the graph is comes this type. Okay, here the volume of NaOH added in ml. According to x-axis, volume of NaOH added in ml. Volume of NaOH added in ml. And here, according to this is a conductance. here the value comes the strong acid versus the strong base. Here, this is a graph. Okay, these are the points. Here, this is A and this is B and this is C. Okay, in this A point, B point, C point. Here you are adding the NaOH, here the value increases and then it increases. This is a strong acid versus strong base. Here you consider this is a equivalence point. This is a V in Young. That V is the volume of base required to neutralize the end point, the acid solution. Here, where V is the volume of base required to neutralize volume of base to required neutralize end point the acid solution. Okay, here this is a V is a volume. Here this get a end point. This is known as a equivalence point. The point is known as a equivalence point. This point, B point, is known as equivalence point. It is known as equivalence point. Okay, here the reaction comes, that is H plus, right here, the H plus Cl minus plus here NaOH. One is HCl, H plus and Cl minus, and another is a NaOH, Na plus OH minus. Na plus OH minus. You get here the Na plus and Cl minus and H2O more. Na plus Cl minus plus H2. So here get solved with NaCl. This is a strong acid, hydrochloric acid and sodium hydroxide, and you get sodium ion and chloride ion and water molecule here. Here the conductometric titration, that is of strong acid versus strong bases. Here you take suppose the solution of HCl. The solution of HCl is a hydrochloric acid, is to be titrated against the HCl is titrated against sodium hydroxide solution, and it is noted initially as well as after successive in the urine. The conductance of acid solution, that is you are using the successive addition of small amount of sodium hydroxide solution. You take a HCl and titrate with a, so here you take HCl, titration is NaOH. You take this, NaOH is in a burette and HCl is in a beaker. And afterward here the conductance of acid solution is very high. Here the H plus ions, the conductance is H plus ions is very high. Here the high conductance, this H, here the first is present only HCl, that the conductance is increases, that is a very highly mobile ions, and HCl is H plus and Cl minus. On adding the sodium hydroxide solution, you are added the sodium hydroxide solution by drop here and into the HCl solution. Here the sodium hydroxide solution is, you are added HCl solution, the beaker containing HCl solution, and here the H plus ions are replaced by slow moving of sodium ions. Here the H plus ions, here this replacing of, that is this sodium ion. This sodium ions are replaced. The H plus ions are replaced, that is a slow moving sodium ions are replaced by slow moving Na plus ions, and hence the conductance of the solution keeps falling till. Here the conductance is falling till after the end point is reached. Here this after end point is reached, then that is all the H plus ions are replaced by Na plus ions. Here after this equivalent point is reached, and afterwards the all the Na plus ions, that is all the hydrogen ions, that replaced as a sodium ions, that is H plus and Cl minus, Na plus and OH minus. This is the reaction. Finally get Na plus and Cl minus, and so all this hydrogen ions are replaced with this sodium ion, and you will get the sodium plus and Cl minus, and this is replaced here the H2O. Here H2O. And after we at the end point, after the attain at the end point, and then the addition of sodium hydroxide solution brings in fast moving OH minus ion. Here this end point is reached. Afterwards you are added sodium hydroxide solution and presence of fast moving OH minus ions, and hence the conductance of the solution against start the increasing. Here these are the fast moving ions, these are the hydroxyl ions are the fast moving ions, and then the conductance is increases. And if conductance value are plotted against, this is a volume of the alkali. This volume of the alkali is a volume of sodium hydroxide in ml, and the curve type is A, B, C. And the point intersection correspond to the end point. The intersected point is correspond to the end point. This is a titration of strong acid versus strong base. Okay, here you only understood here the finding of the strong acid versus and strong bases, only finding the conductance and when it attains equivalence point. Here this is, you are using this HCl and sodium hydroxide. These are the high conductance. Here this not zero, here this is a high conductance, and here increases, and then it is when these sodium ions are replacing with this hydrogen, and here the hydrogen is replaced with the sodium ions, and then the conductance is followed slowly. It is followed the conductance, the all the, so this hydrogen ion is replaced with sodium ions, and it get the solution is neutralized here. The solution is neutralized, and you get a equivalence point. This is a neutralized point. Then afterwards you are continuously adding slowly. That is a titrant with that is sodium hydroxide. The sodium hydroxide is continuously added in a beaker containing the HCl solution drop by drop. You are adding titrant that is sodium hydroxide, and then the hydroxyl ion. In sodium hydroxide, presence of OH minus, that is the hydroxyl ions, and here these hydroxyl ions are fast moving ions. Because of here, the next again the conductance is increases. The conductance is increases, and these two line are intersected at point this point B, and this point B is intersected, and this gives the equivalence point or a end point of the solution. And this is a procedure for the finding the conductance of strong titration of strong acid versus strong base. Okay, second one. This is the first one. This V is always same here. This is a conductance and only changes this one. Next, second one, the titration of a weak acid with strong base. Titration of a weak acid versus strong base. Strong base. Here, the weak acid versus strong base. The weak acid is a acetic acid. You can take the example is a acetic acid. Titration of weak acid against strong base. Here the weak acid is acetic acid, CH3COH, and strong base is a sodium hydroxide. Okay, here a weak acid versus strong base, that is you get the graph is this type. These are the points. This is a equivalent point. Here, this is a B, and C, and this is a equivalent point. This is B1, and this is a equivalence point. And this one is a equivalence point. And here this is the conductance, and this is versus volume of NaOH added in ml. Because of you are taking strong gas, strong base means NaOH. Here the strong base NaOH. Here let us take the acetic acid is a titrated against the strong base like NaOH. You are taken the acetic acid as a weak acid, and this is titrated against strong base. The strong base like that is sodium hydroxide. And then this acid is initially is very low. Here the initially very low acid because of low ionization of acid. Here this is a initial, this is a low, and here we finally here decreasing this graph. Ionization of acid. Okay, here we are adding sodium hydroxide solution. Here take the sodium hydroxide. The sodium hydroxide is highly ionized, and hence the conductance keeps the increasing along this here. you know already, that is the sodium hydroxide is replaced here, slow moving sodium hydroxide, and that is acetate ion is low, and here replacing of here, that is only the slow moving sodium ion, and afterwards the fast moving hydroxyl ion, then it increases this graph, and these two linear graph intersect at this point, and you get a equivalent point here. Here you are taken this in beaker, and here you taken sodium hydroxide in a bearing, and here this you titrate the acetic acid versus the sodium hydroxide solution, and here this is a ionized because of here this is a low conductance because here this is a ionized, and this and it decreases the conductance. Afterwards, it is the sodium hydroxide. When you are adding sodium hydroxide, and then the fast moving hydroxyl ions are replaced here. The hydroxyl ions are present, and then it gives the sharp increase in the conductance, and it gives equivalence point. The curve goes to A, B, and C. This B point gives the equivalence point, and this is a neutralization point. This neutralizes the solution is neutralizes at this point. This is the titration of weak acid versus strong base. This is second one. Okay, next third one. Third one is titration of, that is strong acid versus weak base. Third one. You are taking weak base. Strong acid versus weak base. Strong acid versus weak base. You get the graph is this type. You get a graph is this type, and this is the end point. This point is end point. End point of equivalence point. Equivalence point. And here the values are comes this. And give the name is A, B, and C. This is also same. The volume of here, the volume of strong acid volume of you take A. Titrant is added. Titrant means there is a weak base. Weak base you take ammonium hydroxide, NH4OH. Ammonium hydroxide. And here strong acid, HCl. Strong acid versus ammonium hydroxide. Okay, here this third one is we get the titration of strong acid versus weak base. This is a volume of weak base. Weak base means you take up this ammonium hydroxide. Here in this case, the titration of strong acid versus weak base, taken the HCl and ammonium hydroxide. And here, in this case, you considered as HCl, hydrochloric acid, and ammonium hydroxide. Then it against ammonium hydroxide solution. Then the conductance of HCl solution is initially high. Here this conductance of HCl solution is initially high. The hydrogen ion, the conductance of hydrogen ions are very high because of the graph is comes this slide here. And here the presence of fast moving hydrogen ions as the ammonium hydroxide is added a titrant, that is ammonium hydroxide, along the burette, you fill up with burette, that is ammonium hydroxide is a weak base, and when you are adding the weak base ammonium hydroxide and then the fast moving ions, that is fast moving ions is hydrogen ions. The hydrogen ions are replaced by the slow moving ammonium ions. The slow moving ammonium ions here NH4 plus slow moving ammonium ions, and hence the conductance falls here. Ammonium ions are replaced and the conductance is fall again by the, because of you are replacing the slow moving slower ammonium ions with this this hydrogen ion H plus ions here. I will write the reaction is comes here HCl HCl, right, H plus Cl minus plus NH4 OH. Okay, here NH4Cl plus H2. The NH4 plus first slow moving ions and Cl minus plus H2. NH4 plus Cl minus plus H2. And afterward, when the end point, that is end point is reached, this is reached at end point, and further addition of ammonium hydroxide, this curve reached at the end point, and then further addition of this ammonium hydroxide, and after it changes in the conductance because the ammonium hydroxide is a weakly ionized substances, and here the ammonium hydroxide is a weakly ionized substances, and the line this BC is almost, that is a horizontal. You get a horizontal line, and here it is comes this degrees here. This is because of weakly ionized this ammonium hydroxide, and you get a this curve, and this intersection area, and this intersection point is known as the end point, and or it is the equivalence point. This is the titration of strong acid versus weak base. Next, finally, last one, fourth one, titration of weak acid versus weak base. Here, this is a weak base and weak acid. The titration of weak acid versus weak base. This is a fourth. Weak acid, titration of weak acid versus weak bases. Here the weak acid against weak base, the weak acid against weak base. Here we take an example is weak acid, acetic acid versus versus weak base NH4OH. NH4OH. This is a weak base. Weak acid against weak base. Here the graph comes this slide. This graph comes this type. Here, this is A point, B point, C point. This is equivalence point. Equivalence point. And this is a intersect. This is it gives the end point. Here, that is a value V. Here we are using the conductometric titration. It is considered as a titration of weak acid versus weak base. You have taken the titration of acetic acid with ammonium hydroxide solution. Here we have taken that is acetic acid with ammonium hydroxide solution. The initial conductance here, the conductance versus volume of NaOH is added. Here this is a conductance. Here the conductance of the solution is low. First is low, and here the conductance of the solution is low because of due to the partial dissociation of weak acid. This is a weak acid and this is a partial dissociation of weak acid, but it start the increasing due to the formation. Here it start the increasing. Here this start the increasing due to the formation of salt. Here the formation of salt, that this one. Here the formation of salt, and then the ammonium salt is formed, that is CH3COO NH4. Here CH3CO minus NH4 plus, that is ammonium salt is formed. Ammonium salt of acetate after the equivalence point, the conductivity remains constant. Here it comes. These are the points. And here after it get up and it comes at equivalence point after the conductance is constant. Here this conductance is a constant. Okay, these are the four titrations comes under in a conductometric titration. Here conductometric titration first comes, one is a strong acid versus strong base, that is HCl versus NaOH. Second one is a weak acid versus strong base, that is acetic acid versus, that is sodium hydroxide. Third one is a strong acid versus weak base, HCl versus ammonium hydroxide. And fourth one is a weak acid versus weak base, that is acetic acid versus the ammonium hydroxide. This is the fourth one. Okay, this completes the unit conductance. Okay, next class I will start the new chapter. Thank you.